Hello, this is the first complex numbers video of OCR Pure Core AS Further Maths, and the title is Solving Quadratic Equations with No Real Roots. As you will remember from GCSE, there are a number of ways of solving quadratic equations, such as x squared minus 5x plus 6 equals 0. You could draw a graph. You can complete the square. You could use the quadratic equation. Or where possible, you can factorise. In this example, it's quite easy to spot the factors. We can see that minus 2 and minus 3 will sum to minus 5, and that they will give a product of plus 6. Therefore, the roots or solutions are x equals 2 and x equals 3. So far in GCSE, all your quadratic equations have had two real roots or a repeated real root. For example, from x minus 5 all squared equals 0, you would get the repeated root x equals 5. If I was to draw a sketch of either of these two examples, for x equals 3 or x equals 2, I would have had a curve that looked something like this, with the two real roots. For the repeated root, I would have had a curve where the curve just touches the repeated root at x equals 5. If we look at this next quadratic equation, x squared minus 4x minus 13 equals 0, then factorisation is not so easy. So we can either use completing the square or the quadratic equation. So for completing the square, we would write x minus 2 all squared minus 4, and then not forgetting the minus 13. This would give us x minus 2 squared minus 17. Obviously that still equals 0. So rearranging a little, we would find that x minus 2 squared equals 17, and then taking the square root and adding 2 to both sides would lead us to x equals 2 plus or minus the square root of 17. This would be two real but not rational roots, so you have the surd there, so it's an irrational element. We'll get the same result, obviously, if we use the quadratic equation. So in this case, if we had x equals, let me just write out the quadratic equation to remind you. And here's the b squared minus 4ac element, which is important to think of because we call that the discriminant, and it will be of use to think about in a minute. So that would give us 4 plus or minus square root of 16 plus 52, because we've got the negative 13, all over 2. And if we sort all those numbers out, we would end up with exactly the same two roots. So here's a slide just showing you that completing the square calculation again, and it's worth reminding yourselves that there are two parts to irrational real roots. There's the integer or rational part, and potentially also an irrational part. Let's move on now to look at quadratic equation, for example x squared minus 4x plus 13 equals 0, where there will be no real roots. Again, we could use either completing the square or the quadratic equation to solve this. Let's think about what the discriminant would be. So, b squared minus 4ac would in this case be 16 minus 52 equals minus 36, which we can see is a negative. Either by using the completing the square or the quadratic equation, we would be led to the fact that x equals 2 plus or minus the square root of minus 9. Well, this might be quite a problem because so far we've only been able to take the square root of positive numbers. Even if we take the 9 out as the square root of 9, we know the square root of 9 is 3, we still have a problem of the square root of -1. In the real system, there is no solution for this. However, we can obtain a solution if we introduce a new category of number called an imaginary number. If we assume the square root of -1 exists, we can represent it by I. In this scenario then, we find that x equals 2 plus or minus 3, which is the square root of 9, and then I, which is the square root of -1. So let's look a bit further at this idea. If we have solutions x equals 2 plus 3i or x equals 2 minus 3i, then we find that we can call 2 plus 3i or indeed 2 minus 3i a complex number, which has two parts. 2 is the real part of the complex number, and 3 is what we call the imaginary part of the complex number. It's a bit of a shame really that they use the word complex because it makes it sound more difficult than it is, whereas actually it is no more complicated than considering an irrational number such as 2 plus square root of 17. In the next session, 1.2, we will look at how we can add and subtract these new complex numbers.